You have a laser.
That's a good point. I think
No, that's just the back of my neck. Go, Larry. I'm on it. Absolutely.
All right. Good morning, everybody. I'm Eugene, Software Production Manager here at ODOT, and today I'm going to be talking about microservices. Before we can talk about microservices, we need to talk about monolithic applications. I kind of feel like Charles stole my thunder on that part there. He talked about it in his presentation. But what is a monolithic application? It's a single-tiered software application in which different components are combined into a single program for a single platform. So it doesn't necessarily just mean it's one piece of an executable that just moves. It can be a combination of servers and services within that, but they're all put on one server to run that system. So currently, most of our applications are all monolithic applications. And this is kind of the typical setup, kind of like an e-commerce monolithic approach. So you'll have your desktop browsers, your mobile device will connect to a load balancer, which that'll then have your e-store for your UI interface, and then you'll have some services, and that little piece right there will be your application, which then connects to a centralized database. So the benefits of this particular architecture is it's simple for developers to develop. It's easier from the very beginning. You're starting with a clean code base, and it moves much faster. It's easy to test. You can do endpoint testing by launching the application using the services inside. You can test the UI with Selenium as well. It's simple to deploy. All you have to do is copy it to a server, and then your application is running. So what are the downsides to monolithic applications? Maintenance. As a monolithic application gets bigger, it becomes a little bit more complex, challenging for developers to deploy. Deployment. Anytime you go to deploy a monolithic application, you have to deploy the whole application. Reliability. If there's any bugs in a monolithic application, it can bring down the entire application. Adaptability. As an application from a monolithic perspective gets too large, it becomes hard to change the actual technology in that application. So if you got like 10,000 lines of code in an application and you decide, hey, there's a new technology like .NET Core that came out, well, now you've got to change all of your back-end piece for that one particular application. Scalability. When it comes to scaling a monolithic application, you're just basically moving the application from server to server to server. So if only your orders from your order inventory needs to be scaled up, you're going to spend more of your time with your whole application moving from one service to another server. So it's increasing your cost from that perspective. So what is the microservice approach to developing applications? So a microservice approach to application development is where complex applications are composed of small, independent processes communicating with each other using language-agnostic APIs. These services are small, highly decoupled, and focused on doing a small task, facilitating a modular approach to building a system. So here's kind of like a little video that I got that kind of gives you a more in-depth definition of microservices. Or not.
We're excited for memory.
Yeah, trying to get it to. There we go.
Hey there everyone, DJ here. And unless you've been living under a rock, you've heard the latest coding buzzword, microservices. Microservices, microservices, microservices. In this video, we'll go over what is a microservice, why are people moving to microservices,
Yeah.
and finally,
There we go. All right, let's start this one.
hey there everyone, DJ here. And unless you've been living under a rock, you've heard the latest coding buzzword, microservices. Microservices, microservices, microservices. In this video, we'll go over what is a microservice, why are people moving to microservices, and finally, what you need to do to make an effective microservice. So, what is a microservice? Ask 20 developers, what is a microservice? You're likely to get 25 different answers. Well, here's my best answer. A microservice is basically a self-contained process that provides a unique business capability. Different microservices act in concert as one larger system, but behind the scenes, it's microservices all the way.
Take Amazon.com, for instance. All we see is the website. Behind the scenes, Amazon has a service for accepting orders, a service for determining the list of recommended items to buy, a service to handle wish lists, a service for authenticating credit cards, and so on. All of these services are really mini applications performing a single business capability. What makes this organization interesting is it is not organized around software layers. We don't need to create a web microservice, a business logic microservice, or a database microservice. We're creating microservices around business capabilities. So we have a wish list microservice, an order microservice, and a processing microservice. Microservices communicate with each other through a well-defined interface, usually REST or a messaging queue. The communication is almost always stateless. The microservice data is federated as well. That means every microservice is responsible for its own data model and data. I think that statement just gave heart palpitations to some DBAs. There might be a good business reason to standardize the data platform for all microservices, but the idea is if we're on the team that's building the microservice, we should know best what persistence model we need. It's the latest buzzword, so why not? Seriously though, microservices make our system loosely coupled. We need to upgrade, repair, or replace a microservice. We don't want to rebuild our entire application. Just swap out the part that needs it. Rebuilding isn't a big deal for a small desktop app, but it can be killer for a whole enterprise system. Breaking our system into small parts also allows each microservice to focus on a single business capability. One benefit of this is we can have a small team focused on a simple task. Jeff Bezos from Amazon created the two-pizza rule. The ideal size for a microservices team is one that you can feed with two pizzas. A simple interface means we can use different languages and tools. If we've got a great, well-defined interface, it doesn't matter what language or architecture we use. We can write our service in Visual Basic if we want to. As long as we publish how other services are to communicate with our service, we're good to go. That's why the most common methods for communication between microservices are HTTP and messaging. Everybody supports that.
So what makes a great microservice? Well, we've touched upon a few things already. First, I'll say it again. It focuses on a single business capability.
That isn't to say it only does one thing, just one business thing. It does not mean divide into a web capability, a logic capability, and a native-based capability. That's going back to what we had before. Each microservice should have its own data store. This limits what can change under the microservice. If another group is responsible for the data model, they can also change the data model. That can force downstream changes for many microservice teams, changes that might not help our team at all. Make communication stateless. If our communication is stateless, we can add more copies of the microservice at will. Stateless communication gives our microservice the ability to scale effortlessly. Each interaction with our microservice can be handled by a different instance. Since communication is stateless, great microservices should be able to continue if another microservice fails. Expect the best, but prepare for the worst. That means if we can't communicate with another service, our service should be able to make do. If we're trying to get a list of suggested titles from another service, we'll have a default ready just in case. Our service should never break just because another service broke. Finally, a good team makes a good microservice. We need all the parts represented. That's a designer, web developer, coder, database admin, and operations, all on the microservice team. Representatives on the team. It's everyone we need to make a fully functional application. Up to two pizzas, of course. And that doesn't mean find lots of developers who hate pizza.
Hey, thanks for watching the video. If you like what you're seeing or have any questions, let me know in the comments on EG.com.
So, just to kind of recap there, what are the benefits of microservices? The benefits of microservices is that you get better deployment. You can have services that can be deployed independently, and it allows for continuous delivery and deployment. So that means you don't have to deploy your entire application when you're deploying an application. You just deploy that service. Your application won't go down when you're deploying the service. Just that service will be taken offline. It's technology independent. No longer do you have to commit to a complete technology stack. If you create one service in PHP, you can create another service in .NET, you can create another service in Java, or you can create another service in whatever the new technology is that comes along. Maintenance. It improves the maintenance of your application. Since you're creating small applications or small services that only utilize the business principle or business process, it's very easy to understand what that process is, and there's only one reason for that process to be changed. And then reliability. If one service goes down, your entire application won't go down, just that service. And if we deliver the service correctly, then the rest of the services will work just fine. So what are the drawbacks? There's got to be drawbacks to microservices. It's the application infrastructure. It's new, it's complex, and it turns runtime operations and networking security models into headaches for us. It's something that we haven't done before, so it's going to be a challenge for us to overcome. Testing. When you're testing microservices, because each service is a process, you could have use cases that spans multiple services. So it's going to be harder to test each one of those particular services in unison for that process. Data modeling. Microservices patterns fundamentally change how data is managed. Data is managed as far as being a stateless, so it's not one centralized database. The database is connected to each microservice, so it's going to be harder to maintain data and do governance and reporting on your data. So we'll have to find solutions for that. Agility or Agile and DevOps. Agile has kind of been a term that we passed around at ODOT, saying that we're Agile, but it requires strong Agile principles and strong DevOps practices. We're going to have developers with strong architecture, application skills, and a willingness to adopt new models and pattern designs. So this is what the e-commerce site will look like if we were using microservices. We still have our desktop browsers or our mobile devices, but instead of going to an application or a load balancer, we're going to an online shopping API. And that API is going to connect up to each service, and then those services are going to be attached to their own database. So should we be using microservices?
Yeah.
It depends. Small applications, we won't need to use microservices for. But for large, complex systems, microservices is the way that we're going to want to go. So what's our strategy at ODOT for microservices? You heard Charles talk about the event streaming platform that's going to be using microservices. That's one place where we're going to be using microservices. But we're going to also be using microservices in software development. We've got training in microservices. Everybody on my team went to training for microservices. And we're going to start small. So we have to figure out what projects we're going to work on and how we're going to scale it up. And that's it for my presentation. Any questions?
You said obviously they can be decoupled, but do you have to decouple every database for every microservice?
You don't have to. You can have shared databases for microservices, but the best practice is to have it decoupled so that you can scale it better.
So, I guess currently, are there any candidate projects or applications that you're looking to utilize microservices on, anything on the horizon?
Not yet. I'm still trying to evaluate all the applications that we have to figure out which one would be our best candidate. We don't want to start with an extremely complex, large project, so we just got to find the right one and resource it.
In the database side, each one has their own databases. Is it really to go to database, or they just use like maybe a schema or the tables in a single database?
The actual developers developing the microservice determines what data source you want to use. You can use flat files, you can use a NoSQL database, or you can use a relational database. It depends on what the need for the actual service is to determine the data source.
But no, what I'm talking about is like environment,
Right.
where we have one database, a lot of tables. Is it practical, like if we were to convert environment into microservices, you know, we really don't want to be changing the data structure. Could you assign services to, instead of to a database, to tables, like create a schema and say this schema works with this microservice, this schema works?
No, you wouldn't want to use the schema. You can have your services all point to a relational database, but the problem with that is that your microservice doesn't go and get the data that's specific to it. Now it has to worry about all your other data sets that's inside of that actual database. So you're going to affect your performance from that perspective. So the speed that you would normally get from a microservice, because the data contained within inside of that microservice is only for that microservice. Now you've got data for everything else inside of your database as well. Yep.
So the different data stores for the data store for your microservices, how do they integrate? So like on Amazon, they know that what you ordered, you know what I mean?
Right.
And when it got processed, so that, you know what I mean, you know what your payment is or whatever, you know what I mean? So how do they do that?
They do that through microservices? Yes, they do it through microservice, but each microservice subscribes to the other. So an event is triggered when data changes. There's like the saga pattern for data. So when something changes in one service, it fires off an event, and all the subscribers to that particular event will listen. And if it says, hey, we just deleted this particular record, now you need to go through and update your other stuff as well.
Okay. So there is a relationship, it's just that the store.
Right, it's just going to be
Okay.
that something has to be triggered over here to say, hey, I've deleted something, and then on this side it says, okay, I heard you, now I'll go and do whatever I need to do to my side.
Okay.
Great.
Does this add a layer through ODOT in any way?
No.
Good answer.
Yes.
What is the process of, or methodologies, guys, that you guys are going to use to publish, like, you know, how to access these microservices goes out like this one?
Not sure yet. I'll have to figure that part out once we get the architecture built and designed. And I think a lot of it depends on what application we start with.
Yeah, it would seem that this approach would require a lot of discipline at all levels to actually implement it as designed or as intended. Do you have any misgivings that sustained attention to detail won't be, you know,
It's going to be a change in the way we do software development completely. Because it's no longer going to be just software developers developing the actual microservice. They're going to be teams. You have to create microservices in teams, kind of like what he was saying. You have to have the business as a part of the team for creating that microservice so that they all have that particular knowledge of that industry. So there are going to be challenges for that, and that's something that we're going to have to figure out how to get that working.
Now, in the microservice, you have like where the front page is displayed, where it's calling several different functions, all displayed it on the same page. So it would be the function of the main application or whatever, to call all the microservices, get all the data, aggregate all the data for display.
Yep. Well, there's orchestrator
Yeah.
for that handles that. And I can't tell you about the orchestrators since I haven't actually developed and completed the whole microservice project.
Do you foresee basically IT personnel being embedded in the business?
I do. I think there's going to be certain teams that's going to go and be part of the business, and then there's going to be kind of a core software development team that's going to coordinate with each one of those teams as we build an application. Yes.
Is ODOT's approach for microservices going to be for homegrown solutions or also looking out for vendors that support this sort of a framework?
I think we're going to start with homegrown solutions, and if there is something out there that we can bring in, then yeah. why reinvent the wheel? Anybody else?
Is there something that enforces relational integrity? So like using the e-commerce example, if you have a product that's available through your catalog or something, and then it gets added to your shopping cart. And so I know you mentioned that there's an event bus that says, oh hey, this was deleted or whatever. But is there anything that actually enforces like, oh no, this product really doesn't exist? It's in your shopping cart, but it no longer exists. If an event is.
There's nothing that actually forces that. We would have to design that. But it could be a potential downfall or a break within the application. That's all we're
Yeah, so do you anticipate, or I know is performance differences between applications architected this way versus?
I think we will see performance increases. But I also think what we'll also see is kind of when we start moving to the clouds, we'll see cost reduction because we'll be able to scale up our applications and provide the services when we need it. And then we can downscale when we don't. Yes.
How do you, so say a microservice has been developed and then it evolves. How do you foresee changes between the microservices communicated between the development?
They're going to have to communicate that. That's going to be when something, that's one of the things about microservices is that it's heavy on communication. So if something is changing in planning and somebody in construction needs to know about that, those two teams need to communicate. Planning can't just go off and make their changes and not let construction know what the changes to their services are, because then that could cause problems with their actual service.
All right, and then on the same end, I suppose if one group needs something from another group,
they need to communicate as well.
And also, I agree, you can have multiple versions of it, right?
Yes, you can have multiple versions of the same. Right.
I just want to say that this is actually a very mature technology. I mean, a lot of the big players that Charles mentioned in his speech have been using this type of stuff alongside Docker containers for like 8 to 10 years now, where it's not like this is bleeding edge, it's been out there. But my suggestion would be, if you're approaching a microservices approach, don't start with your SQL database and figure out how to use it. Start with the microservice itself and ask how can it deliver value to the system, and let that dictate how your data store will change. If you start with a SQL database, you will basically take your traditional system, implement it in a bunch of microservices, and it won't do what you want. It won't add value, but it'll add a lot of coding churn to your effort. So,
And the same goes for the actual code that you use. Just because you know .NET doesn't mean that that's going to be the best code to use for your microservice. Figure out what the process is and then determine what's going to be best. Maybe PHP is the best for your UI piece, and then maybe something else is best for your backend side. Any more questions?
So with breaking out the different parts, logging becomes essential. So I know there's like application insights in Azure and things like that. And, are there other tools that would help facilitate adequate logging?
There is, I just can't think of the ones from, there's a list of most of them I've never even heard of before. Put this together. So, any other questions? Thank you, everybody.